The breadth and the depth and the knowledge that comes behind Kubernetes clusters is something that people are constantly in pursuit of. The abilities of Kubernetes clusters, especially as they continue to get more updates and continue to be enhanced more, will grow more and more. So, this video is just how a little bit of an explanation about how you can create a Kubernetes cluster on Azure and what its functionality is, but there's so much more that goes into what makes a good Kubernetes cluster and what you can do with it. So Kubernetes clusters are also called AKS, which stands for Azure Kubernetes Service. Those are often used interchangeably. There's also K8S. It has an 8 because there are 8 letters between the K and the S in the word Kubernetes. So these are used so frequently that people have made some acronyms for them instead of calling it a Kubernetes cluster every time. So if you take a look at this picture right here, these are all different applications, node pools, different things that the Kubernetes cluster controls. Now, at the center of it all is what's called the control plane. And this is kind of this is the head of it all. It's sort of the brain, the heart, whatever, of what makes a Kubernetes cluster. So the control plane is what's in charge of taking everything and drawing it together and making it so that it all works together. And then what you decide to do with that is up to what you want to do with your Kubernetes cluster or the needs of your project. So the control plane is what drives everything together. Now, a great benefit of having this is that if the control plane detects something within it that is no longer needed, or maybe it just needs to be updated, but you don't want to update the entire Kubernetes cluster, or maybe there's a security issue, then it can let go of whatever it is that is. It can let go of the node pool or the container or anything so that the rest of the Kubernetes cluster can continue to function. And that's one of the key benefits of using a Kubernetes cluster. So let's get a little bit more into what a Kubernetes cluster is. So within the Kubernetes cluster, you are going to have a node pool, multiple node pools possibly. And within each of those node pools, there's going to be nodes. So these nodes, and you can see that it's something that just keeps on breaking down more and more. You can think of it as a tree which branches off in different directions, and then those branches will likewise continue to break off into smaller and smaller bits so that you can try to isolate everything from it one another while also having a central hub that brings it all back together. So you have the node pools, and then you have a certain amount of nodes. You can have a lot of nodes or a few nodes. Within those nodes, you have pods. Now, the pods are what are going to host a lot of the applications that you are going to have for your Kubernetes cluster. So when you want to deploy something to a Kubernetes cluster, you need to deploy it to a node pool, which sends it to a node, which sends it to a pod, which sends it to a container. And if you look at this, we can get a little bit more, magnify a little bit more on what the nodes are. The nodes are going to have pods, and then those pods are going to have containers, and there can be more than one container per pod. And then within those containers, there are applications. There's a lot of things that go into this. There's Docker, which really helps to deploy these different images that we need to these pods. But that is the basic functionality of what a cluster is that it tries to isolate everything and it tries to bring it all together so that it can work. So what are some of the benefits of using a Kubernetes cluster? So auto-scaling is a very helpful one. When you define the pods that you are using and the nodes and the node pools, those you give them a range of what it is that they're trying to accomplish. For example, you will say have anywhere from 1 to 5 nodes in my node pool. So that means that it knows that if there's not a lot of traffic going through it, not a lot of data being processed through it, that it will scale down to 1. But if there's a day where there's a lot going on, then you want the nodes to increase. And Azure and Kubernetes know that these aren't things that you will watch all the time. So they have auto scaling, which means that depending on how much is used, it will increase it or decrease it. And this is also a strong form of resource utilization. So when you don't need certain resources, then it will get rid of those resources for you. And then when you do need more, then it will use it more so that you can keep up with demand that's coming on your Kubernetes cluster or your applications within your Kubernetes clusters. You have different namespaces. When you create something within a Kubernetes cluster, you need to specify which namespace it is used for. Now, with the different scenarios that we have found ourselves in, there will be different testing environments, and there will also be different production environments and very important things that you have to do. So having different namespaces is a good way of creating some metadata so that it can separate itself from other things. You deploy containers, and then you deploy applications into those containers. And it can also hold secrets within it. So it's useful for carrying some secret values within it, and it has some functionality of just saying that there's a secret in there, and if you have proper permissions, you can view those secrets on the Kubernetes cluster. So here I am on the Azure portal. I'm on the Kubernetes services, and I have a few different options that I can choose here for the different kinds of Kubernetes clusters that I want to make. I'm just going to choose a Kubernetes cluster that I can control a bit. So let's specify the resource group. We always have to specify the resource group. And we are going to give the cluster a name, AKS 01. I am going to give it some different availability zones. And I can specify the different pricing tiers that I want for the AKS. So there's free, standard, premium. Free is probably more just for testing. If you are making a Kubernetes cluster for the fun of it or to learn something, then you'll probably want to go for free. And then standard is what you'd want in most other situations. As you can see, it provides SLA of 99.95. And if you are using an availability zone, then it's 99.9 instead. But there's premium as well, depending on your needs. But I have rarely seen situations where premium is needed. Usually standard is almost always what's good enough. You can specify the Kubernetes version, and they will pick a default version. So you will see here that there's 1.31, 1.32, 1.33. What Azure generally recommends is that you go for the previous version, previous minor version as it's called, which is the second number that's in the middle, -1. So what that means in this case is that 1.33 is the newest minor version. But Azure doesn't exactly recommend that you go for the newest version. They say it's better to do something that's a little bit safer. So they have picked 1.32 as the version instead. And then the last number is the patch version. So they started it with 1.32, and then they realized, oh, there's some improvements that we can make here. So then they made 1.321, and then they've made even more improvements and made 1.332.2, and just so on. So they wanted you to pick the latest patched version because this is the one that has the most enhancements and security patches between all the different 1.32s. So these ones are still getting patched out. We should probably give them some more time. So that's why they recommend this one, but you can technically pick any one you want. There older versions, but those versions are no longer supported. And there is a page that Microsoft has put out that points out the different times about when a Kubernetes version was created and how long it's supported for and when you can't use it anymore. So here's the page here. We have Learn Microsoft AKS Kubernetes supported Kubernetes version. So we come here and tells us a little bit more about the different versions that there are. And then you can see here about some different versions, when they were released, when there were previews made for them, when they were general, and then when they reach the end of life. So when they are no longer going to be allowed to use. So you can see here that version 1.31 is reaching the end of its life on November 1st of 2025. Now, this means that if you are using a cluster that is using 1.31 and you are past November 1st, it doesn't mean that you can't use it anymore. It just means that it's losing support, and it is going to lose more and more support as time goes on. So you're taking a risk by using an older version of a Kubernetes. But they try to always make it so that you have 3 different versions that you can choose from. So they've told us that we have 1.31, 1.32, and 1.33 that we can use right now. And soon 1.31 is going to retire, and then we're going to have 32, 33, and 34 that we can use. So this is a page that you can go for where it tells you about the different versions that are out there. So let's pick the normal default version that it recommends. All right, let's go to the node pools. Okay, so currently Azure is having a little bit of a problem right here. When you create a node pool, it's going to create all the nodes within it with a certain image. And this one has been having a little bit of problems with what I've been using. So I need to go and get one that I've tested off camera and that I'm a bit more sure of. So this would normally work, but because it's been a little shaky recently, I'm going to remove that one. It says that we need at least one system node pool when making this, so I'll have to do that myself. Okay, so I need to specify it as a system. I'll just call it node pool 1. And then I need to specify which VM size I'm going to make for it, which is the node image. So I'm going to put one in. Like I said, I've done some testing on this one, so this one should work. All right. So I'm going to add that. Oh, I selected. I'll have to redo that. I remember selecting system, but it unselected it for some reason. So select that, and I've selected system. Okay. All right, now let's go to our tags as well. As always, let's make sure that we're assigning it the proper tag so we know what's going on with it. And these are other things that you can put in with the Kubernetes cluster. But let's go ahead and review and create this one. So the only thing that I'm making here is the control plane and other things that it needs for it to function. Now, when you are creating these, they need to be within a subnet. And what is common practice is that these things should be put inside of their own subnets so that they don't get mixed together with other resources. So it's often good to declare a subnet with your virtual network. And then that subnet, you'll say AKS01, which is the name of mine. So we know that that subnet goes to this Kubernetes cluster. And now that Kubernetes cluster has its own subnet. It's not going to mix up with other things. So it's good. All right. So this deployment is going to take a while. These Kubernetes clusters take a little while to create, so I'll pause this. And we're done here. Let's go to the resource, the AKS 01 that I made. So we can see all the different information here. You begin to notice a pattern with all these different resources that the Azure does for you about how it decides to display all the information to you. You can go into the JSON view to see exactly in here what all the different code is. This is easier to read. And we can go into the node pools as well. I created the node pool here. More node pools can be added to it. And then it has the nodes that it created inside of my node pools. It has 18 pods. And this is a Kubernetes cluster. I'm going to delete this because these things are quite expensive and I don't want it to cost me a lot of money. But this is a small overview of how to create some Kubernetes clusters and what they do.